This is going to be lesson 1. We're going to talk a little bit about WHMIS today. So these are your learning objectives here, guys. Illustrate an awareness of WHMIS guidelines and demonstrate safe practices in the handling, storage, and disposal of chemicals in the laboratory and at home. As far as, safe disposal of that stuff, I would tell you that, right? I would tell you where to put those chemicals if they're safe, in some cases, to go down the drain. Sometimes yes, and sometimes no. We collect them in a bucket, and then we take them out to the landfill, and they kind of separate it into hazardous materials. And at the end here, we're going to identify examples of chemistry-based careers. So in case you want to do something with chemistry, you're like, this guy's awesomely funny, and I want to do some chemistry stuff, and I really enjoy this class. I could do some like chemistry, chemical engineering, or cosmetology, or food processing, or I'll give you another list there. Okay, so that's what's going to happen. WHMIS, what does it stand for? This you want to know, of course. Workplace Hazardous Materials Information System is what that stands for. Okay, and make sure you know that. That's probably the biggest thing about WHMIS. Okay, that's what it stands for. Workplace Hazardous Materials Information System. Okay, and this is just so you know what it is, but basically it's an information system that was designed to give workers and employers and students more information about the safety and health hazards associated with chemicals that are used. Okay, so it just gives you some of the information about that. Okay, and basically, if you ever heard of WHMIS, did you guys do WHMIS in Science 9? I forget. You probably did, right? It just tells you what to wear. Like, right? Do you need gloves? Should you be careful? Is it corrosive? Is it going to burn you? Is it going to catch on fire? Right? Kind of thing. All right. WHMIS labels. WHMIS labels will be placed directly on the container. Do all products and chemicals contain labels? Yeah, pretty much the dangerous ones, yes. This is an example here. Here at Skull and Crossbones, exclamation point, and we'll get into what each one of those means, okay, down the road here. So once again, don't worry about that too much, but those will be, we'll have notes on each one of those, and those you should know, obviously, okay? So here we go. WHMIS supplier labels. The label made by the employer contains the following information. So you will see this as part of every label, WHMIS thing. It's got a product identifier, and basically that tells you what is it. Okay, so what is this certain chemical, right? Initial supplier identifier, who made it, so what it is and who made that product. Okay, whether it be, I'm trying to think of the chemistry company that makes most of the chemicals, but I can't think of it right now. But that would be on there as well. Okay. Pictograms. It's a picture that identifies the hazard. So it will, like I said, with the O with the flame on top, it means it's an oxidizer. It catches on fire fairly easily, or corrosion. A signal word indicates the severity of the hazard. So how dangerous is it? Okay. A hazard statement describes the hazard. So what could possibly happen, and precautionary. So basically, how do you protect yourself from that chemical? Okay, would be on there as well. Okay. WHMIS workplace labels. Okay, labels made at the workplace and attached to containers need to contain the following. So they need to have the product name. Okay, safe handling precautions. So it may include a pictogram. Okay, we should maybe write this stuff down, I think. A reference to SDS. Okay. What does SDS stand for? A safety data sheet. Okay. If you have a copy of the notes in front of you, you probably have this already, right? It's on there, should be, I think. So that's fine. But in case you don't. All right, so a reference to the SDS safety data sheet. What does the SDS stand for? Like I said, safety data sheet, and that'll be an answer that you're going to have to know in your notes. If you want to see a sample SDS, if you click on that link in the notes, it will show you an example of that. Okay, which you don't really need to worry about right now, but if you wanted to see that. Okay, so SDS safety data sheet. Okay. So they need to contain a product name, Safe handling precautions, like I said, it may include a pictogram and a reference to the SDS, or the safety data sheet, for more information. So quite often these chemicals will have this information on the label, but there'll also be a safety data sheet that goes with it. And usually it's in a binder somewhere. So when you go to work at, I don't know, No Frills or Sobeys or whatever kind of thing, they should have somewhere there, and you guys should have this, right? If you guys are working, I don't know, yeah. Safety data, like they should have a binder of these chemicals that you may encounter. Okay, and what are the safe handling precautions and things like that. So if you're doing cleaning or whatever kind of thing, obviously they should have some kind of a sheet there that says how would you protect yourself and all that other stuff that goes with it, what are the dangers, and so on and so on. Okay, so probably just those three things there are good, guys. And SDS, that'll be something that you're going to have to name in the notes farther down the road here. Okay, is that good? All right. So pictograms. The hazards can be, oh, that didn't work out, identified as either a health hazard or a physical hazard. Okay, so a health hazard or a physical hazard. Most of the classes of hazards are identified with a pictogram, and a pictogram is an image that helps us to easily identify the hazard. Okay, obviously we need to know what those pictograms are if we're going to be cautious of those things. Right? So in this case here, obviously looks like it's a fire, yes? So we'd want to be careful that it doesn't catch on fire. Most of the classes of hazards are identified with pictogram. We need to know what that pictogram looks like and what it represents. Okay? So they can be identified as either a health hazard or a physical hazard. All right? Now, here's all the symbols that you would see. Okay, and we're going to go through each one of those very quickly here. So if you want to kind of write down a general idea of what each one does kind of thing, I don't think you need to write it all down. It's in your notes, like I said, in Google Classroom. But if you kind of want to get an idea of or write those down, that's fine. We're going to go through each one individually, so you don't need to write them down yet. Okay. WHMIS symbols. Controlled products will be identified by one or more of the following symbols. Remember, there could be more than one symbol attached to this. Okay, so it could be corrosive, yet it could catch on fire as well. So we need to be aware that it could be one or more of these. Okay, so here we go. Flammable. Okay, so that's the one for flammable there, and of course flammable is for fire hazards and flammable materials. Okay, that got kind of cut off there. Let me fix that. I can bring this down a little bit here. Okay. Examples of this include gasoline and ethanol, which is an alcohol. Okay, usually not the kind that you would want to partake in. Okay, this one is the kind they put in gasoline. You don't want to drink that. Okay, usually. So for fire hazards and flammable materials, gasoline, ethanol, or alcohol, kinds of like isopropyl alcohol, rubbing alcohol, things like that. Okay. You would probably see this thing here. Okay, so that would be flammable for that one there. Okay, a circle O with a flame basically attached with it would be for an oxidizing material. In other words, it really readily gives off oxygen or a substance that increases the chance of fire. Okay, examples include bromine, nitrates, chlorates, and nitric acid. So very dangerous chemicals, and they readily give off oxygen, or they basically would increase the chance of a fire. Okay, we know that fires need oxygen to burn. That's called a combustion reaction, which we'll look at later on here, towards the end of the unit here a little bit more, a little down the road here, and that's quite common with those. Flame over a circle, oxidizing. Okay. So we would call that the oxidizing one. Okay. Gas cylinder would be another one. Okay, you quite often see these for gases under pressure. So if you go to Costco, right, or somewhere else that has these propane tanks kind of thing, gases under pressure. Okay, so that is gas cylinder for gases under pressure. So propane tank. Quite often, if you go to I don't know if I should say this now, but if you go to an old folks home, okay, or somewhere, someplace where all the old people live, you'll quite often see them delivering canisters of oxygen, because some of them need that to help them breathe or whatever. And those, if you see on the side of the truck, you'll see that symbol, okay? They deliver canisters of oxygen, which are, of course, pressurized and whatnot, okay? Okay, corrosion. You know, that's probably the best example right there. Batteries, right? Acids, things that eat. So corrosion. Quite often if you buy a new battery from somewhere, you'll see that symbol there, which means obviously the sulfuric acid that's in the battery can, you know, readily eat something. And in fact, that's why the terminals sometimes get corroded over a period of time, okay? So for corrosive damage to metals, as well as skin and eyes, and they attack and chemically destroy. Common examples include acids, of course, like hydrochloric acids, sulfuric acids, particularly bad, and bases as well. Okay, bases as well. Sodium hydroxide is not particularly very nice. Okay. In fact, having said that, another place you would see these is actually sometimes on cleaning bottles. Cleaning bottles often involve bases, and bases are good for cleaning because they kill skin cells. So basically that's how you disinfect things, with bases. So like you know, Drano and things like that would quite often have ammonia as part of that. That's that smell, you know, that smell that you smell when you open up Drano or whatever kind of thing. It's like, ooh, that's strong, right? That's what you're smelling. You're smelling a base, and they attack living organisms basically. So that's why you don't want to get a base on you. Bases are actually more dangerous than acids are. Okay. Yeah. Yeah, they can. Yeah, they can. Sometimes they use different methods for that though too, right? They have their system there. All right. Environmental. Environmental. So may cause damage to aquatic environment. So these have been updated. Okay, and by 2018, we kind of need to adapt these. I didn't include the 2015 ones because those are kind of obsolete pretty much already. May cause damage to the aquatic environment. So examples include PFCs, which are perfluorinated compounds, and you would get those from basically things like personal care products, fast food containers, raincoats, electronics, stain-resistant carpet. Okay. Non-stick cookware, okay, and microwave popcorn bags. So PFCs are that, you know, that coating, right? I mean, a lot of the pans now don't have that anymore, but Teflon is an example of that actually. So Teflon pans are not great to cook with. They say that you know, you have to get them very hot in order to break down that compound. But normally now they don't have any more PFCs in them, okay? So PFCs, like I said, and that was some in electronics as well. That kind of, I don't want to say styrofoam because that's not true, but fast food containers, that plasticky, slippery stuff kind of stuff, that's what they're talking about there. And that's environmental, okay? Environment. Exploding bomb, everyone loves this one, eh? Kablammy. For explosion or reactivity hazards, an example would be ammonium perchlorate or nitroglycerin, which are both very unstable. Ammonium perchlorate. Okay. So for explosion or reactivity hazards. Okay. Skull and crossbones, obviously, that's not good. Can cause death or toxicity with short exposure to small amounts. Skull and crossbones. So things that are poisonous or things that are toxic to you. Okay. Um, Carbon monoxide, pretty common gas that sometimes, of course, carbon monoxide when basically when fuel doesn't burn completely. So this can happen in a house. That's why we should have carbon monoxide protectors in our house. Yes. Go to Costco. They're cheap there, 30 bucks. Buy more than one. And that is basically what happens is when fuel burns, you should get carbon dioxide. Okay. So when you burn carbon, you should get carbon dioxide. But sometimes you don't. If it's not a complete combustion of that fuel, you will get carbon monoxide. Okay. And when that happens, like I said, it affects you. And these are some signs here that if you're ever feeling like this, you probably, especially if you're at home or whatever, you probably should think about maybe getting outside and getting some fresh air. Sodium cyanide is a poison, okay, so that's more of the poison kind of thing. But if you're getting headaches, not feeling well, okay, and I know these symptoms are obviously, you know, sometimes when you're just not feeling well, but dizziness, breathlessness, collapse, and then loss of consciousness eventually is what takes place, okay? All right. Health hazard, okay? So health hazard may cause or be suspected of causing serious health effects. Way back in the day, we used to have this thing called asbestos. They used it as insulation kind of thing. Asbestos is known for the little fibers breaking off and getting into your lungs and causing cancer. Okay. And of course, they're not allowed to use asbestos anymore to make any kind of buildings or anything like that. So, all right. So health hazard. Okay. And these are kind of hard to see, so I apologize for that. You're probably better going and look at on Google Classroom there and seeing what those, you can kind of take a look at what they look like and things like that. It's a little easier probably there than it is on here. Okay. Exclamation mark. So exclamation mark basically means may cause less serious health effects or damage, less serious health effects or damage to the ozone layer, which is a part of the atmosphere. So for example, methylene chloride can cause damage to organs and skin irritation. Okay. So exclamation mark may cause less serious health effects or damage to the ozone layer. Part of the atmosphere. And then this one here, of course, if you've played any kind of game, yes, almost all of them have this, don't they? PS4, Xbox. No? Oh. Okay. No? Yeah. Yeah. Oh. Fire hazardous infectious materials for organisms or toxins that can cause diseases in people or animals, used in medical equipment like needles, for example. So quite often they'll have this as biohazard, right? I don't even know what those games are. So for organisms or toxins that can cause diseases in people or animals. And usually you'll see that used in medical equipment like needles and things like that. Okay. 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 And once again, you'll have this in your notes there, guys. But basically, you know, the flame one here, for example, flammable, self-reactive, pyrophoric, self-heating in contact with water, emits flammable gases, organic peroxides. Flame over the circle means oxidizer, exploding bomb, of course, explosive, self-reactive, organic peroxides, gas cylinder, okay, corrosion, skull and crossbones, biohazardous. What is this one? Health hazard, of course, with the lungs. An exclamation mark would be, of course, once again, hazardous to the ozone, or maybe not quite, like I said, irritation, skin sensitization, sensitization, things like that. Okay, and environment, of course, aquatic toxicity. Okay, so that kind of gives you a summary of those again. So once again, that'll be in the classroom for you there. Okay, and here are some chemistry-based careers, okay, that you may be interested in, perhaps. Biochemist, of course. Obviously a combination of biology and chemistry. Analytical chemist, environmental chemist, cosmetic chemist, chemical engineering. Usually when we think of chemistry careers, we think of chemical engineering. And a polymer chemist. A polymer chemist basically makes long chains of carbons, simplified, I guess, very simplified, but long chains of carbons that we use in industries and things like that. Plastic shopping bags at Sobeys, polymer chemist kind of thing. So you would come up with new things like that kind of, okay? And like I said, that's in there. Jobs with a chemistry background. So things that have a chemistry background, of course, are patent law. So if you're interested in, law, for example, you could be a patent law chemist kind of person. So you would know whether, somebody comes up with a some new idea. Did someone steal that, that reaction or that kind of thing from somebody else kind of deal. Education, obviously. Forensic science. So that's cool. Science journalism, food science and technology, chemical management and sales, medicine, and pharmacy. Okay, so lots of different careers with that chemistry background there. All right, good. Chemical engineer, in case, like I said, that's probably the most common one. There's also a link there in case you want, but chemical engineers conduct research, develop and optimize processes, design and select equipment, and provide technical and management services for plants that convert raw materials into a wide range of end products. For example, chemicals, pharmaceuticals, food products, fuels, plastics, metals. Okay, probably the most common thing for chemical engineering around here would probably be the oil sands, where they would convert oil into different end products. Okay, gasoline, diesel fuel, jet fuel, etc., etc. Okay. All right. I think that's the end of that. So there's lesson 1 there. Now what we're going to do here is we're going to go to, like I said, go to Google Classroom. There's a worksheet there for you guys to fill in, and I'll leave this up here. And if you want to come back and